See, layer 2 devices switch. Layer 3 devices router. Firewalls, layer 4 and above. You tell me, which is the best place to provide security? Is it 2 or 3 or 4? It is 2.
All of those.
It's right from layer 2 you should start providing security. If you start from layer 2, layer 3 is protected, 4 is protected. So, we talking about firewall for security is meaningless if you don't provide security on switch. Most of the attacks can be prevented if you do simple switch security. You don't need even a firewall. It's like, keeping the house door open and trying to lock only that room where you got a lot of money. No, better you lock the door, main door. Why you keep your main door open? Right from the main door, if you are living in an apartment, you cannot go and lock the gate because it's common for most of us. Lock your door, main door. Then everything inside the door, the living room, the kitchen, the everything is protected, preserved, protected. Talking about firewall and protecting network is like just locking the safe where you kept your valuables. Switch security. Understanding switch security and issues. You see, this picture says most of the attack happens in the access layer via the switch. So we have to protect from access layer itself, from the switches. What do we have in access layer? Switch. Distribution and core layer, we'll have multi-layer switches or routers. And edge and the DMZ is where we will have firewalls and routers. So we need to protect our network everywhere that is possible, and most importantly, we have to protect our network on switches itself. If you harden switches and routers, you can prevent most of the attacks. Hardening, tightening, security. You see, when you talk about vulnerable, rogue access points, means these are the ways through which an attacker can enter into our organization. Someone can spoof a switch, a wireless router, a bridge, a hub. So attacks may come in any form, but if you will harden this device, if this device is very strict, these rogue devices cannot enter our organization. We are going to see 4 different categories of attacks. I'll go a little bit faster now from now. You can use the video to master it because we don't have much time. I have to finish most of this presentation today itself. MAC layer attack means attacks based on MAC address. VLAN attack, attacks using VLANs that are existing in our network. Spoofing attack is spoofing like a legitimate device, spoofing like a genuine device, and stealing our data. That's spoofing attack. And then some of the attacks on the switch devices. Now, MAC flooding attack. One of the MAC flooding attack is man in the middle attack. That's what you're seeing here. Or you can also say this is MAC flooding attack, because man in the middle attack means something also. So this guy is also a middle guy, he's an attacker, someone in the network who is turning to be an attacker. What he does is he floods the MAC address. How can a computer flood a MAC address? One computer will have only one MAC address. How can an attacker flood the MAC address? Meaning he is sending packets with different MAC address. Those MAC addresses are not of their own computer. They're not of their own. They are just generated by some software. So this PC wants to confuse our network, wants to spoil our network. So what this PC does is it sends numerous invalid source MAC address. Meaning every packet that comes out from this computer is going to have new MAC address. What will happen when a packet comes to a switch port, let's say port number 3? When a packet comes, the switch will start learning the source MAC address. The switch learns source MAC address. Now, we see numerous invalid source MAC address, meaning the switch starts learning numerous invalid source MAC address. That's the danger. You see, as the packet arrives, switch's habit is to learn MAC address from the incoming frame source address field. Listen carefully. The PC is sending frames, means packets. In layer 2 we call this frames, right? As the frames enter the switch's behavior is to learn the MAC address coming on every frame. The MAC address that is seen in the source field. See, the actual MAC address is C, but it is sending my MAC address is X, my MAC address is Y. So the port starts learning all this new MAC address against the port number 3. Again, it is said here numerous. Don't think it is sending only 2 MAC address. For the sake of picture, they have drawn 2 MAC address, but there are thousands. Thousands of MAC address coming in. And switch starts learning all the MAC address. What is wrong in that? What wrong is the switch is learning invalid MAC address. There is no one called X or Y in reality. So there is no use of learning such MAC address. One thing. Secondly, learning this invalid MAC address is going to occupy the space in the MAC table where a genuine MAC address can be kept. What I'm coming to say is, if invalid MAC address keeps coming, it will fill the entire space that is allocated for MAC address table. And when the MAC address table is filled completely, and there won't be any place for new, genuine, legitimate MAC address to be saved. As a result, the switch will stop learning MAC address. Listen, if switch stops learning MAC address, will it be really having the characteristics of switch? No. Switch is considered to be an intelligent device because it learns MAC address. When switch stops learning MAC address, why it stopped learning MAC address? Because there is no space for the MAC address to be learned. The entire space is consumed already, filled already by invalid MAC address that was coming from the attacker. Now in any port, in port 1 or port 2, if a legitimate MAC address packet comes, the switch will not learn MAC address because the MAC table is full. So what happens, because the MAC address is not learning, between A and B, the conversation will not be one-to-one, it will be to all. Meaning, when A sends packet to B, because there is no MAC address of B in the MAC table, the switch will flood it to everyone. The packet will be flooded always like a hub. Hub only will flood the packets always to all the ports. But here, because there is no space to be learned, the MAC address to be learned, switch will start flooding the packet via all the ports. What is the advantage for the attacker? For the attacker, he can listen to all the conversations. One. Secondly, if there are too many people in this network, this broadcast that is happening will cause congestion, and the network will perform very poor, or sometimes it will stop allowing traffic because there's too much broadcast. Switches have got more number of ports, then there will be more number of devices connected. More the number of devices, if MAC address is not learned for those devices, flooding always will be there, and bandwidth consumption, the CPU consumption, everything is going to be high because every packet should be sent via all the ports, and this will spoil the network. That's what you see in the second picture. Normal traffic is flooded out all ports because no CAM entries exist for a valid host. This is an attack. Did you understand the attack? Anyone? Do you understand it? Wonderful. The solution is port security. The port security can prevent this attack. What is port security? Limiting the number of MAC address that can be learned on a port. See how simple is the solution? By default, any number of MAC address can be learned on a port. That is what made this attacker to go and consume the entire CAM table space, MAC table space. If you would have limited the number of MAC address per port, attacker cannot send more than that number of ports into the switch. Problem is solved. Did you understand the solution to this problem? Setting the number of MAC address per port will prevent this MAC flooding attack. Say for example, port number 3 where the attacker is. If I would have set the number of MAC address that can be learned on this port is only 1. Because I know only one computer will be connected to that port. And one computer means only one MAC address is needed. If I would have set the MAC address, number of MAC address on that port as 1, attacker cannot do this MAC flooding attack. When he sends the first MAC address that is learned, when he sends another MAC, when he sends a new MAC address on the same port, switch will shut down the port. Switch will know, oh, there is an attacker here. Only one MAC address should come. I already learned one MAC address. Now he is giving another MAC address, which is suspicious. So port number 3 will be shut down. For how long? For 300 seconds. If there is something called error disabled recovery is configured. If that is not configured, then switch will be shut down forever. Only when you go inside the port and say shut down one more time and no shutdown, the interface will be kept down. Let me repeat again. You need to set the limit on all the ports so that if there is a MAC flooding attack, that won't be successful, because when the number of MAC errors exceeds the limit, the port will go down, shut down. If it is shut down, to bring it up, you need to go inside the interface. Manually, you need to shut down once, repeating again. Manually, you need to shut down once, and then bring it up by saying no shutdown. Listen. When the MAC addresses exceed the number, because of the violation, it got shut down automatically. Because the port security is what? Enabled. What is port security? Setting the number of MAC address that can be learned. That is called port security. It's a Cisco's feature. Now, if anywhere a violation happened, definitely it is going to shut down the port. How we are going to bring it up? Go back to the interface, say shut down one more time manually, because earlier it was shut down because of violation. Now the administrator enters inside the port and saying shut down once manually and then no shutdown. There won't be any MAC address as of now, because just now only it has come up. All the old MAC address got removed because it got shut down. As it comes up, It is ready to accept packets. Now, when the first packet comes, the first packet is learned. If another packet comes with another MAC address, again it will go down. This is how we prevent this MAC flooding attack. We saw that port security is the solution. Port security restricts port access by MAC address. See, not only you can set the number of MAC address per port, you can also say which one is an authorized MAC address to come inside the port. But again, it's an optional one. You see, I can go to this port and say the number of MAC address allowed is only one. Additionally, I can say which MAC address, something like this. I can say which MAC address. Not only that, I can say what action to be taken if some other MAC address comes. If second MAC address, I said only one MAC address for this port. If the second MAC address comes, what should I take? What action should I take? Can be defined. The default is shut down. There is also another protect and restrict. These are the three actions that you can take. I'll tell you the difference between those things, three things later. But what I'm coming to say here is port security allows us to define the number of MAC address. Optionally, it allows you to set the violation action. The default violation action is shut down. Thirdly, it also allows you to bind a MAC address to the port and say only if packet comes from this MAC address you can allow. All right. Now you see here, to configure port security, first of all we have to enable port security. So you need to go inside the interface and say switch port security. Boom. That's all. That's the first line. Secondly, you can set the MAC address limit. Same command. You need to begin with the same command. Switch port security. Maximum. How many MAC address? One or two or three. All right. If you don't say this, I told you this is an optional one. If you don't say this, then only one MAC address will be allowed. Thirdly, you can optionally say which MAC address you want to allow. Fourth, you can set the violation action. The violation action by default is shut down. You can say protect, you can also say restrict. Enable port security and specify the maximum number of MAC address that can be supported by the port. This is one of the options. You can also say which MAC address, and you can also say violation action. And to verify, you type show port security, it will show what all interface the port security is enabled. And if you notice here, only on 5/1 and 5/5 and 5/11, the port security feature is enabled. See, you may not be enabling port security on all the ports because you may be comfortable with most of the ports because they are connecting to your employees. But few ports may be connecting to the public. That is where you want to protect. So let's assume these are the three places which is vulnerable, where the attackers may enter. That's why they have enabled port security here. Now, here it is said that maximum number of MAC addresses that is allowed is 11, 15, and 5. Currently learned MAC addresses all 11 is consumed. Out of 15, 5 is consumed, so 10 more MAC address can be learned on this port 5.5, and then one more MAC address can be learned on 5.11. And if you see here the violation actions, if 12th MAC address comes in here, it's going to shut down. Here, if 16th MAC address comes, it's going to simply restrict. It won't shut down the port. If 6th MAC address comes in here, because 5 is the maximum, this is going to protect. Now, what is the difference between these three? Okay, they will not mention what it is, but I'll explain you. See, shut down, it will shut down the interface. Restrict, as the word says, restricting, meaning it will ignore the 16th MAC address coming in. Only the first 15 MAC address packets it will continue receiving. When the 16th MAC address packet comes, it will be keep on ignoring. That's all. That is how it restricts. This one is protect mode, meaning maximum of 5 MAC address can be learned. When the 6th MAC address comes, it will ignore that packet with the 6th MAC address, those packets with the 6th MAC address, it will ignore at the same time. It will also generate logs. So that the administrator will know how many packets were violating this rule. So that the administrator will have a clear evidence. And the administrator will take some action according to the evidence. So protect will not only restrict the illegitimate packet, it also creates a log and say how many times the attacker was repeatedly sending the packet, which is restricted. So shutdown shuts down, restrict ignores those illegitimate packets, protect not only ignores the illegitimate packet, it also increases the counter and generates the log, increases the counter. Which counter? This one, the violation counter. If 10 packet comes, means 10 packet comes with a new MAC address, 6th MAC address, then it'll say 10. If the 11th packet comes with the 6th MAC address, then it will say 11. So by seeing this counter, the administrator will be now in an alert mode. He will go and keep an eye on this port. He will go and keep an eye on the device connected to this port because that's the one which is generating this MAC addresses, which are not accepted. Okay, anyway, I don't want to spend much time on this. We have a lot to learn. Show port security interface 5/1. You see, this is the interface 5/1. If you want to know much in detail about this interface, this is what the command that we use. Show port security interface fast Ethernet 5/1. It shows the maximum number of MAC addresses allowed is 11. Total number of MAC addresses, configured MAC address, meaning manually you have said these are the 3 MAC address I know which is allowed to come in on this port. Rest 8 MAC address can be any MAC address, but number of MAC address is only 11. These are all aging time. These are all not that important. So far, no violation happened. Port security is enabled. Okay, one more thing here is violation. If violation happens, the port is going to be shut down. Currently, the port is up because there is no violation. Show port security addresses. It will show all those addresses that are learned on the port security enabled interface. And it will also show you how the MAC addresses got learned here in this table. These two are secure dynamically, meaning as the packet comes in, the MAC addresses are learned, and these MAC addresses are manually configured by the administrator on those ports. Secured configured means, we have configured it saying these are the MAC addresses that is expected on this port. Secure dynamic means port security is enabled, but MAC address is not given by us. It got sticked as it comes in. There is also an option called sticky, meaning when I say 3 MAC address or 5 MAC address, okay, let's say 11 MAC address. You may feel very difficult for you to type those 11 MAC address to say the port, these are the 11 MAC address are legitimate. So instead of you typing, sometimes when we do typing of MAC address, we may do error. Instead of doing manually, writing the MAC addresses manually, all 11 MAC addresses, what you can do is in a secured environment, you can enable the feature called sticky so that the 11 MAC address will be sticked permanently to the DRAM, and when you say copy it and start, it will be saved to NVRAM. So every time when you reboot the switch, the MAC addresses that are allowed will be always there, and only those MAC addresses are allowed to come in. So sticky MAC address stores dynamically learn MAC address. Did you understand the problem and the solution? We are going to the next one. Did you understand this one now? Right. Next is there is a concept called AAA. AAA stands for Authentication, Authorization, and Accounting. Authentication, Authorization, and Accounting. What it is? If someone is trying to log into this device, before logging in, it will ask the username and password. And that we all know. But we can have this in a centralized way, meaning instead of going to every switch and putting the username and password, you can put the password and the username on a centralized server. Anyone logs into any switch, the switch will go and ask these guys, hey Radius, hello TechX, can I allow this guy inside? He's trying to come inside. Is he allowed? And Radius will say, yes, he's allowed. Then switch will permit the traffic to come in. If Radius says no, then no packets can enter in. What I'm coming to say is you can have the usernames and passwords of allowed people in a centralized server so that you don't need to jump into every single device to put the username and password. For this, you need special protocol. One is Radius, the other one is TechX Plus. What is TechX Plus? Say earlier, before TechX Plus, this TechX Plus is now Cisco's, okay? Before Cisco's TACAX Plus, there was one TACAX industry standard, but it was a failure. It got removed from the standard. So Cisco took that name TACAX. They did some modification to the old TACAX, and the modified version of TACAX is TACAX Plus. TACAX Plus is Cisco's. Radius is still an industry standard. TACAX Plus is Cisco's. So you cannot configure TACAX Plus on a non-Cisco device, non-Cisco switch. You cannot tell a non-Cisco switch to use TACAX for authentication, authorization, and accounting. Radius is available for every vendor to use. TACAX is for Cisco. The other differences are TACAX uses TCP, Radius uses UDP. The other difference is in TACAX, these three things are three separate sessions. Authentication is a separate session, authorization is separate, accounting is separate. Whereas in Radius, authentication and authorization happens in one session, one go, and accounting is a separate. So in Radius, authentication authorization is done together in one conversation. Whereas in TACAX, authentication is separate, authorization is separate, accounting is separate. What is authentication? Checking who they say they are is authentication. I'm Professor J. Okay, if you're Professor J, where is ID? Okay, I show the ID. Alright, sir, you're inside. You can get in. That is what authentication is. Authorization is, okay, you're Professor J. Okay, fine. See, sir, you are allowed to go only to that building. You're not supposed to go to any other building inside the campus because you are a visitor. You are allowed only to that building. Your access card that we give you will only open that door. This is what authorization. They give me permission to access their premises. That is got all authorization. So even in networking, not everyone can do everything when they log into a device. Some will be restricted to do configuration. They can only do show commands. They are called as supervisors. They're not administrators. Only an admin rights guy can enter into a switch and put some configuration. So setting that authorization limit can also be done. Third is accounting. Fine, Professor J, you can get into that building, and there's a small cafeteria. You can use it, and there's a venue for you. You will see a label with your name. You can go inside the classroom. That's your classroom where you're going to teach, and rest of the places you are not allowed to go. Fine. Okay, I said okay. And then I go straight to the classroom, let's say. I never used cafeteria. That is what accounting is. The security guy knows that I never used cafeteria. That's accounting. See, the authorization given to me is to use cafeteria as well as the classroom. But he did not see me any time in the CCTV camera entering into cafeteria. So he's giving an account saying Professor J went to this training room and then he left around 4 3:30 the office. That is what accounting. With the permission, with the authorization, what he has done is what accounting is. So doing these three things when anyone enters into our device, what are the three things? First, authenticate the person who is trying to enter. Secondly, grant him the level of privilege, level of permission to do XYZ things inside the network. And then accounting is keeping track of what he has done with the authorization, the permissions.
Cisco IC works.
Repeat again.
Cisco IC.
Yes. Before ICE, there was another device called ACS, Access Control Server. ACS is now ICE. Now, this is the command to tell the switch what type of authentication, authorization, and accounting. Should I use Radius or TechX or first Radius? If Radius is unreachable, then TechX. If both are unreachable, uh, maybe use the local database. So this is the only command that you need to know to enable TechX or Radius on the switch side. We are not focusing on configuring these things. We are just focusing on the switch security. So if you're going to use any of these Radius or TechX, what need to be done on the switch? You need to just tell the switch that I'm trying to authenticate only by using method 1 maybe Radius, method 2 TechX, method 3 local login, something like that. Next topic is .1x. This is a popular way to security feature. This is also same like TechX and Radius, AAA service .1x. But the difference is AAA is done when someone tries to access the switch, telnet to the switch. Whereas .1x is for the traffic that is passing through the switch. If anyone wants to access the network via the switch needs to authenticate them before allowing them to pass through it. You see, when you go from one country to another, you may not have a direct flight. You'll be landing in some transit. They still do checking. They check your boarding pass. Sometime, if you need to collect another boarding pass in the transit, they even check your visa copy, just a visa copy. It's not immigration, but they do authenticate you before they board you into another flight. That is what transit. So now a switch is a transit here. Someone from outside wants to access some device inside your network, but to go to inside your network, they need to transit through the switch. And the switch is going to say, wait a minute, let me first authenticate you, and then I'll allow your traffic inside. For that, you have .1x, 802.1x port security, port based authentication. Again, this is possible only if you have special software on the client side. On the client side, whoever sends the packet, whoever wants to talk to you or inside of your network, they need to speak through the client software. As they try to speak through the software will carry all the authentication information to the switch, and switch will first see whether the authentication is true, and then it will allow those packets to enter in. All right, this cannot be tested in the lab without the software. And these are the commands to enable AAA. Right, so in this chapter we learned about MAC flooding attack. The prevention is port security, and then we learned about the AAA radius attacks, and then we learned about .1x. AAA and .1x, the difference is AAA is for those traffic that is trying to log into that switch or that router or that device, whereas .1x is for those traffic that is passing through the device. Now, next. See, lab part of this chapter will be done a bit later. Let us focus on only the theory part as of now. VLAN attacks. Protecting against VLAN attacks, meaning VLAN is a logical switch inside a physical switch. VLAN is a virtual switch inside a physical switch. Inside your physical switch, you may have like, just for example, 100 ports. But you don't like 100 ports to be in one group. So you create small group, let's say 4 groups, 25 port in one group, which is called VLAN 1, 25 port in another group called VLAN 2, another 25 in VLAN 3, another 25 in VLAN 4. So you created 4 virtual switches inside that big physical switch. If any broadcast is sent to one of the member of VLAN 3, it will go only to the other 24 computers in that same VLAN. That is what VLAN is. VLAN breaks down the big broadcast domain into small broadcast domains, so that when any broadcast is sent by one of the VLAN 2 member, will impact only those members of that same VLAN 2, not the members of VLAN 1 and 3. That's the big advantage of VLAN. You have a logical separation, you have an isolation between the members of different VLAN. But the problem is, here attacker is using those VLANs to damage us. Let's see how to protect against those damage. First of all, we are going to see what sort of attack is possible using VLAN. Secondly, we will see how can we protect ourselves from those damages. The first one is VLAN hopping attack. What is hopping? Jumping. Jumping. You see, one workstation is in VLAN 10 and a server is in VLAN 20. Now, attacker wants to gain access to both. Which is not possible in a normal situation. This is an abnormal because it's an attack. Attacker gains access to VLAN 10 as well as VLAN 20. You know how? attacker negotiates trunk. Usually, the ports where the computers connected or configured means should be configured as an access port. This is a good practice. But the problem is this administrator has not followed the good practice. He did not configure access. He was he was new to this networking job. Maybe he was an accountant earlier. So he he don't know that he has to put access. This accountant is checking whether everything is working fine. Everything is working fine because the default is auto mode on the switch port, meaning the port can be access or trunk. Because it was auto mode, the attacker was successfully negotiating trunk. What is trunk? The port that can carry multiple VLAN traffic. So what happened now? The attacker is negotiating trunk, and attacker is sending a traffic with VLAN 10 so that it can access VLAN 10. Some traffic with VLAN 20 so that he can access VLAN 20. Because his port is trunk port, because the port to which attacker is connected is a trunk port. It will allow packets coming from various VLANs. The attacker is pretending as if he is a switch and he is sending VLAN 10 packet to access this, VLAN 20 packet to access this. But it's not really a switch, it's a computer, but the software that is installed in that computer is a attacking software which can do this, which can negotiate trunk. When the port is in auto, it can negotiate trunk, so it negotiates, and it has gained now access to all the VLANs if it is trunk. So using that access, the attacker now freely enters into all the VLANs, hopping between one VLAN and the other. And you know the solution for this attack. You know how to prevent this attack. What is that? Do not leave any port auto. Do not leave any port auto. Auto is default. Auto means automatic. It can become a trunk if someone requests for a trunk. If an attacker requests for a trunk, it will become trunk if you leave it auto. Don't leave it auto. Just put it as access. You see, putting it as access port will give access only to that VLAN, not any other VLAN. Next is the MAC ACL, access control list. Like you have ACL for routers, we also have ACL for VLANs. Traffic within the same VLAN can communicate, but you can restrict it by writing VLAN ACL. Even though the members are of same VLAN, the members of the same VLAN can be restricted access by writing VLAN ACL. Router ACL will prevent traffic between different VLANs, that is layer 3. VLAN ACL restrict traffic within the same VLAN, which is layer 2 ACL. Layer 2 ACL works based on the MAC address within the same VLAN. Layer 3 ACL works between the VLANs using the IP address. These are the commands. We will not get into the commands now. Next is the private VLAN. This is somewhat important chapter for Cisco. This is a Cisco topic. I want to just skip as of now. I'll start this topic as a fresh topic when we start next class because there are a lot of things to discuss here. But I would like to quickly tell you a few things about this so that tomorrow it will be easy. Private VLAN is a VLAN inside VLAN. VLANs inside VLAN. And these VLANs that you have inside the primary VLAN, let's say this is primary VLAN 100, the secondary VLAN 10, 20, 30. The secondary VLAN can be in two different modes, and this primary VLAN will be in Prometheus mode. This can be in a community mode. This can be isolate mode. You see here it is isolate mode, community mode, and Prometheus mode. Prometheus. All right. More detail about this, I would like to start fresh next class. Right. So that's about the VLAN attack. Next is the spoofing attack. Spoofing attack means what? Pretending to be someone and making others to believe that I am that person. You know, that is spoofing, acting, acting, proofing, spoofing. For example, you are allowed inside the campus, but someone pretends to be you, someone acts like you and gain access into the building, which means he has spoofed you. She has spoofed you, right? So spoofing can be done. So instead of a legitimate DHCP, a rogue DHCP may spoof and give IP addresses. An attacker may give you IP address. If he gives you IP address, he will also give you gateway DNS. The gateway and DNS may be attacker's network. So all your traffic will go through the attacker's network, which is dangerous. So we should be very clear from whom we are getting our IP address and gateway address and DNS. If attacker gives the gateway address and IP address and the DNS address, our packets will go through the attacker's network. Attacker can now see what is being communicated to others, and they can make use of those data to spoil us. This is also called as a man-in-the-middle attack. How this is happening, how to prevent it? How to prevent it is snooping. By enabling snooping, you can mitigate spoofing. You can mitigate spoofing by enabling snooping. Snooping is a solution. We'll talk about these things in coming class. All right. Next is IP source guard. IP source guard uses DHCP snooping. By using the DHCP snooping, which we see in the previous topic, you can enable another feature called IP source guard to verify whether it is coming from the right source. Next is ARP spoofing. ARP spoofing also depends on the DHCP snooping, right? So DHCP snooping table will be used by dynamic ARP inspection. You see, DHCP snooping will be used by dynamic ARP inspection. So these topics are connected to these first topic. This chapter also I'll go in depth in next class. I'm just running through this so that you will get an idea what all coming next. At least some terminologies you learned now. Next is some attacks based on the STP related. Spanning tree uses bridge protocol data unit, and using this BPDU also an attack can be done, which will be spoken in the following days. Root guard, BPDU guard, and so on. Loop guard, UDLD, and about CDP we have already covered. I'll also revise one more time and how to have a secure telnet, SSH, and so on. All right, and then the good practice, and then the chapter ends. That's going to be a big chapter. At least another 2 days we'll be spending on switch security. Hope you enjoyed. I hope you enjoyed today's class. It's important. The video will be presented to you in a few minutes.